2015 Jeep Patriot with the 2.4. This one's got a remanufactured engine in it. Engine's running great. Oil level's good, no leaks. But we have a code that comes up quite often, and it's a P000A. Camshaft 1 position slow response, bank 1. So that's the intake camshaft response. So it's got VVT, variable valve timing. Well, right here is a variable valve timing solenoid right there for the intake, one for the exhaust, camshaft position sensor, 3-wire Hall effect, exhaust position sensor. So what we're going to do is we're going to take it for a drive and read our data and see why we have a camshaft 1 position slow response. This one does have a new VVT solenoid in it. So what we're going to do is take it for a drive. Maybe it's the wiring going to the VVT solenoid, which I doubt because it would have a circuit code. Camshaft position sensor, I doubt. We can hook up the oscilloscope to prove that. But I wonder if the cam phasers with this remanufactured engine has issues under there. So if that's the case, where we got the engine from, that should be covered. But we got to do some troubleshooting to find out what is going on. So I'm back in the car. What we're going to do now is we're going to escape out of the Jeep program. I want to look at freeze frame data. So I'm going to go and look at global EOBD, so I can look at the freeze frame and see what we have for our tolerances in the mode 6 data. Not the freeze frame, sorry, the mode 6 data I meant. I mean, we could do freeze frame too, but it throws it pretty actively, so that would just tell us, you know, what temperature, mileage, but it seems pretty active, so I'm not worried about that. But we do want to look at the mode 6 data to look at the tolerances. So we go to mode 6 for Jeep, so it pulls up. And like I said, we're in generic or EOBD Jeep. So let's go down here, right there. VVT, VCT monitor bank 1 was only bank 1 because it's a 4-cylinder. Here's your intake, here's your exhaust, and your other test. Well, if you look at the intake, the min is 0 degrees, the max is 2.5 degrees, and we're at 4 degrees when we run it. So it failed. That's why it's throwing the code. Well, the exhaust is perfect. Everything's good. So that's why it failed. We're, you know, at 1.5 degrees over. So we're going to clear the codes out. I'll show you the data, how we're going to graph it, kind of troubleshoot this Jeep. So we cleared the codes. We'll read them again. There should be nothing right now, and there's not. So we're going to go to live data, pull up our data and graph it. See what's going on here. I just wonder if we got a mechanical issue with the cam phasers. Not sure yet. We'll troubleshoot it down. We want to eliminate all these possibilities before we, you know, pull the valve cover. So we'll pull up some data here. We want intake, desired and actual. Let me get these graphs set up so we can merge them together. So I'm just going to do 0 and 250 so we can see it easier. Why am I doing this? Is so I can merge the graphs. So if you look at this, the blue is the desired. That's what the engine computer wants, 119.8 right now. The actual is 119.8 or 9, which is good, right? When we drive it, if the blue goes up or down, so should the green. Let's see what it does. Try to film while I drive, which is probably not. It's kind of hard. All right, sorry about the glare. Well, we'll see what it does here. It doesn't always, only desires, you know, advance or retard the timing when the computer wants it to, depending on engine load and conditions. So there, you see the blue go down? Man, that glare's bad. But the green didn't go down. Right there. I'm trying to get up here in the shade. Yeah, right there. It wants that. That's the desired, but the green needs to match it, and it's not matching on the intake one. Well, just moved everything. Slid back on the seat. Okay, there we are. So it's not matching up. So depends how you're driving. It could be more dramatic. Just depends on engine loaded conditions. Right there. So eventually, yeah, we're way out. It's not even moving at all. So now let's compare the exhaust. It's the same sensors, and just see if we get what kind of results we get from that. Did not throw a code yet, but let's go ahead and check that one for the exhaust. Back to live data. And this one's got a new VVT solenoid in it, so I wonder if there's a mechanical issue going on or a wiring issue. But if there's a wiring issue, there would be an actual circuit code. So let's look up cam again. Let's do exhaust. Do the same thing. Set up our graph. 50. Now this is the other side of the engine, obviously. I expect this one to be good because we never had any codes for it, and the mode 6 data was good. Okay, blue exhaust, one desired, green actual. Same situation, just on the other side, the exhaust side. Again, it depends on engine load and conditions, when it actually needs it. Going to do it right now. I did this earlier and it matched up perfectly, just depending on conditions, what it needed. Of course, no, it ain't requesting anything. Get over here and do it again. I'm a dead stop. Still nothing. I'm trying to get out of the sun here, but it ain't working. I just keep going, I guess. Here, look, it went down. Blue went down, so did the green. See, it's matching. That's the exhaust side, so that's good. But the other one, the desired went down, but the actual never went down. So there lies our problem. Yeah, so I mean, you can clear the codes, which I just did a little bit ago, again, before I captured this data, but it's the mode 6 will show that again. So yeah, so let's look at the mode 6 again for the intake cam and see where it's at. All right, so there's going to be codes. Don't worry about the permanent one. That's until we fix it. There's going to be a pending one, I'm imagined. I know there is in the Jeep program. Right now we're using the EOBD, but yeah, pending. Same thing, code. So code it out, go to mode 6 for Jeep. So I know the exhaust is good, but the intake is not good. It's out of specification. Even though it's got a new VVT solenoid in it. So now we're just gonna check the wiring to the solenoid. Power going in, the computer controls the ground, pulse width modulated. Check the cam sensor, which I'm sure is fine. Hall effect sensor, make sure the square wave's good. And then it may be mechanical, which we're gonna have to address where we got the engine from and see what we can do. Yeah, right here, 2.5 degrees, and it was all, that's the max. Min is 0, max is 2.5, and it's at 6 degrees, so it failed. Everything else passed. This is cool because this is your tolerances. So look at your misfire data, which there's none. So yeah, it definitely failed. So now we got to, like I said, we're gonna check wire integrity, check the cam sensor, and then if that's all checks all good, we're gonna have to pull the valve cover and take a look at the actual cam phaser, which would be a mechanical issue, which should be covered under the warranty of the engine, and go from there. All right, so now what I'm gonna do is check the solenoid and wire integrity going to it. So what I have is I have my breakout lead kit from AS Wave. There's 2 wires going out. I have them broken out, power and ground. Got them to my oscilloscope there. To my oscilloscope on my scan tool there. Got my other scan tool there plugged in. I could use that scope on that tool. I could use that scope on this tool, and I'm just using both tools right now. So there's a lot of options there. But when you look at the wiring diagram, sorry about the glare again. VVT intake, VVT exhaust. So intake, 2 wires, brown and white, black with a white tracer. So it goes to ground, and then this PCM here controls this through duty cycle. So I go back to the oscilloscope, hit play. I got it broken out with my breakout leads, like I said, and the oscilloscope hooked up. So I'm going to go over here. I'm in my active test. I'm going to hit 20%, and this will change. Once I hit play. So there's 20%. I'm going to hit 40%. Let me turn this light off. It's glaring bad. There's 40%. I'm going to hit 60%. I could do this on the Autel Ultra too. I could use a split screen, which is pretty cool. See that? You can do all that, but I ain't worried about that right now. So I'll hit 60, or 59.993, which is, we'll call it 60. Just changing the duty cycle. So that tells me the power and ground to the solenoid is working. And I don't know if you can hear it in the video, but it is changing. So that's the duty cycle, so that's reading correctly. So let me hit 80%. There it is, and you can even see the positive duty ratio is 80%. So I'm going to hit 100%. No, hang on. I'm going to hit 60%. Right there, 60. I'm going to hit 19 or 20%. So everything's reading accordingly. That tells me the power and grounds that are good. So that plunger's working. So what now we're going to do is you do the camshaft waveform. Make sure that's reading correctly. If that is, then we got a mechanical issue we have to talk about. Alright, so I'll show you what I got set up now. Cam crank waveform. So camshaft position, there's 1, there's 2, we're on 1, 3 wires, 5 volt, sensor ground and signal is the blue. So that's when we want a back pin. Got the scope hooked up still. And I'm back pinned on the blue wire there. And then if you look, I'm reading it. Good waveform, 0 to 5 volts. That's a little bit of hash in there from noise. I'm not worried about that. You could put a filter in there. But I'll put it on the other it overranges this from the spikes in the hash. But I can take this probe, put it on the other blue one here. Well, I'm not connected all the way. Same thing. That's the exhaust one. So we got a good camshaft position, which I expected. But so yeah, now I think it's in the cam phaser. So what we're gonna have to do is, we proved all this. VVT solenoid's good. The wire integrity's good. The camshaft position sensor's good. We're going to pull the valve cover off and get to the phaser and see why this thing is not moving. So that is it for this part of the video. Well, I keep saying I'm done, but I put it back on the cam sensor. just want to show you this low pass filter on this Ultra. So you go here, low pass filter. I'm going to turn channel A on. 3 kilohertz should be fine. And look, cleaned this signal up a lot. But it's a good signal. So like I said, it's mechanical. I'll pull the valve cover, get to the cam phaser. So that is it for this video. I know I keep saying I'm done, but show you the service data here, what it's talking about. But back to the Mold 6 data. Minimum 0 degrees, max 2.5. We're at 6.2 degrees, so it failed. The exhaust minimum 0, max is 6 degrees, and we're at 0.2. So exhaust is way good, but the intake is way off. Well, because it's never moving, right? So it has to be something mechanical in there. But if you read in here, here's your schematics. Bank 1, camshaft 1 position, slow response. Oh, it ain't responding at all. Tells you how it works. Tells you all the set conditions. The actual camshaft position does not match the desired camshaft position during camshaft phasing for approximately 30 seconds. Engine oil's good. It's not aerated. And all the filter stuff's good. The VVT stuff is all good. And guess what? Camshaft phaser or oil control valve. So we have to take that apart because yeah, we got it's a reman engine, but obviously when they remanufacture it, they had an issue, so we got to pull the valve cover and work with who we got it from to cover the labor and the parts. Now just very frustrating because of the I don't know, shitty parts that people produce these days. So but we'll get it addressed and we'll get it fixed. That is it.